Hey guys, how's everything going? This is JSer. In this video, I'm going to do a sorting method again in JavaScript. If you already knew this, you can skip this video. I'm going to try insertion sort and bubble sort and quicksort. Yeah, these three sorting method and try to write as fast as I can. Okay, so now we're getting an array and we need to sort it. Okay, and we need to sort it right. Cool. Let's first try a bubble sort. Bubble sort means we loop through the items over and over again. Every time we compare the adjacent to nodes, and if the first one is bigger than the next one, we swap it, right? And then this become 1, 5, and then 5, and compare with 4, we swap it. So we did this round. This biggest one will be put at the last one. So right, 5 will be here. And then we continue swapping, and the second biggest one will be the heap put here. So until the first until there's only one node left, and the array is sorted. So this is called bubble sort. Let's try to do it. This is all inline. Okay. Let's first create a util function called swap. We don't need to swap. We could use destructuring assignment. Yeah. Cool. So let's loop through it. So yeah. For let the n, okay, the n equals arr.length minus 1, n is bigger than bigger than 0. Should the last one should be counted? No, the n. This one will the first two will be checked for the last round. So n is bigger than 0. It's right, and n minus. So for each round, we will start from 0, and then start was smaller than n, start plus plus. And then yeah, this is the end. The start will end at here, right? Yeah, and then we just compare the start and start plus 1. These two numbers, right? Yeah, if arr start plus 1. If it is smaller, if it is equal, we do nothing, right? So we only swap when they are smaller. So if it is smaller than arr start, we swap it. So with swap, we could use destructuring assignment plus arr start plus 1 equals arr start plus 1 arr start. So we've done this swapping, and then start will be moving to the next one, and then this will move the largest number to the end actually. So when this is done, we return the arr, right? Let's try log. Log our solution down. Yeah, it works. Let's try add some equal numbers. Yeah, it works well. This is a bubble sort. Obviously, the time will be in quadratic, right? To n to the power of 2. N square, yeah. Okay, this second one is insertion sort. The insertion sort is similar to bubble sort. Rather than we loop through all the elements to the end, we could just try to sort the beginning of this array, right? We sort these first two, and then when we are sorting 4, we try to move the 4 to the right position, right? Yeah. Suppose like if this is already sorted, and then we will try to insert this 1 into the right position. We loop it back from this 4 and then 1 and found the position. And yeah, while we're looping, we'll just try to swap it, right? We swap it, and move it to right direction, right position. And then so these numbers are all sorted, and then we can move to the next one. Cool. This is another sort. As we analyzed, we should start. We should also loop through the end, which we just start from 1 to the end. So for let n equals 1, and then n smaller than ar.length and plus plus. Now we have determined the end, we will loop through the back, right? We'll compare it. So for let j equals n, and then j equals n, and then j will be bigger than 0. J was, if it's already at the first, if j is already at index 0, we don't need to swap it because there's nothing before it. J minus minus. So what we will do, actually, we will, if it is smaller than the previous one, we will swap them, right? If not, we will break, actually. So if arj is smaller than arj minus 1, we swap it. If not, if it is equal or bigger than it, then we should break. We do nothing, right? We break. And then finally, we return an array. Yeah, cool. So we have successfully sorted our array. 1, 1, 2, 2, 3, 4, 5. Yeah, that's what we want. Obviously, this is also n square. Yeah. The last one, I'll try the quicksort. Well, quicksort is something like not that easy to explain. So the idea is every time we choose a pivot, how should I interpret it? We cut down, we split this array into 2 parts, and then try to sort them independently, right? But when we separate it, we hope to find a pivot, like the number in the middle. For the example here, I hope we can find a number of 3, and then if we choose a 3, we could move all the numbers smaller than 3 to the first half, and the bigger than 3 to the next half. And then, so based on the 3, if we just see this number 3, this array is sorted because it's smaller to the head, larger ones to the rear, and then we can just sort the separate parts, right? Yeah. So while we do that, actually we could just yeah. Let's define. When we are sorting the first half and the second half, we will call this sorter again, right? So let's say it's a quicksort with ARR start end. Cool. To do. And then we quicksort ARR 0 ARR.length -1. Cool. Now what we do here, We choose a pivot. Actually, we could just choose the start. Pivot equals ARR start. And then we will check like start from 0. And then we choose this is pivot. So we will loop through all the rest numbers, right? And then find the smaller numbers. And yeah. So let's define the index to swap equals start plus 1, where this is the next number which the smaller than pivot should be placed at, right? So for let I equals start plus 1, I smaller to n I plus plus. If ARI, if it is smaller than it, if it is smaller than pivot, we will do what? We will swap it, right? If it's smaller than it, so 1 is smaller than it, we swap it, and so 4 is bigger than it, we do nothing. Wait a minute. The smaller okay, for 1 here it's smaller. We do nothing. Now we swap it, but it's actually the same position. So actually it is not changed. Then go to 4. 4 is smaller than it. We swap it. Okay. This one is 2 extreme cases. Let's try to 3. Smaller, and then we got 4. 4 is bigger than it. So we do nothing and go 1, and then we swap it. Okay. So yeah. So we swap it. If it is smaller than it, we need to swap ARR index to swap ARRI equals ARRI ARR index to swap. Yeah, after we swap it, index to swap should be incremented, right? So after this is done, it means all numbers smaller than pivot is put at the beginning and at index to swap -1. Yeah. So now what we do, we swap the pivot to the last number, right? And we swap the pivot, which is start. This should be index swap to swap -1. This one, this is start. So now the indexes. There's something wrong. This is something wrong. I'm sorry. Yeah, so the numbers before this index to swap one before this pivot is already sorted, and then what we do, we will just sort array start index to pivot -2, right? And then sort ARRs index n. Cool. So but how should we end this? Well, if start, like there is only one element, like n start is only one element, it should be the same, right? Okay. So start is bigger or equal to n, then we return. If there's only one element, we don't need to sort. We only sort if starts smaller than equal n. Okay, and then Quicksort. Okay. Yeah, this is our implementation, but there is an infinite loop here, infinite call stack. Let's try to solve it. Okay, start Quicksort 0 and -1 start n. If this is the case, we return, and we choose the pivot as start. and the index to swap is next one. We start with the next one to the end with plus, and then if this one is smaller than pivot, we need to swap. So swap ARI and ARI to AR index swap +1. So when everything is done, yeah, this all the numbers should be at the smaller numbers should be in the head, and the start, we swap the start pivot to the last numbers, which is smaller than it. So this is it. And then we sort start with index to swap -2, and sort ARRs index swap n. Well, I don't find. Oh, this should be n, man. Oh no, start. Oh, I cannot find any problem here. Let's log start and 0606. Really? If we speaker, we do nothing, right? We comment this out and lock the array 211 23 45, which is right actually. Index swap 4. Yeah, we get it right. We move 3 here, and actually we will swap. Shit! I know what happened. This should be a quicksort, man. And then we return the array. Cool. Now you see we have done it. That's for the quicksort. So let's see. Quicksort. So if ideally every time we could actually move sort half of them, and this will every time it's like the sort time will be 2 to the half of it, something like this, right? Tn equals to like Tn minus 2 half of it, and we sort it plus this is it. This is we 1 round plus O n. Yeah, so this actually is 2. It should be 2 Tn divided by 4 plus n divided by 2, right? Plus Tn. I'm sorry. This is n. Okay, I'm sorry. It should be n. Actually, this is 4 T and divided by 4 plus plus 2n. So actually, this what the n should be equals to log 2. This divided by 4. So this actually should be 2 to the power. And this is actually 2 to the power of log 2n. Right? This will be T1. T1 is 1. So plus 2n times log 2n, right? So this should be log 2n log 2n. So yeah, it should be n log n. n log n. Cool. So this is time complexity for quicksort. Averagely, right? If we didn't choose the right pivot, it will be for the worst case. For the worst case is that every time we will, this is the good average case. For the worst case, every time we will actually loop through all the elements over at just we root out only one element, like the last element, right? So it's suppose that it's already sorted, like 1, 2, 3, 4, 5. For this case, actually, we choose one pivot and we need to sort this and then sort this, right? So its worst case is n squared. Cool. So that's all for this one. I hope it helps. We use 21 minutes to implement 3 sorting method. One is bubble sort, and insertion sort, and quicksort. They have time complexity of n square, and n log n averagely. And the worst case is n square for the quicksort. But there's another thing about this sorting method, and you see at the bubble sort, the first, if there are same numbers like 1, 1, the first one, no matter how we swap them, the first one was always be before the next one. So it's still, this sort is stable, and this one is also stable. But a quicksort, you see, we didn't, right? For quicksort, like we first write 3, and we got 2, 2, 2, 4, 4, 4, 4, right? So the last step of swapping the pivot, we swap these 3 actually. We swap these 3 to the last 2. So these 2 will be moved to the beginning. So now these 2 is before this. The position of these 2 are not kept, right? So it's unstable. Okay, so that's all for this one. I hope it helps. See you next time. Bye bye.